Looks like we've just about got everybody here. Good afternoon and welcome to our special session. I first want to thank Mike, who's sitting over here, for asking for this panel, and I probably have to give special thanks to, I'm not sure if thanks is the right word, to Dr. Bill Lewis, who volunteered me for this. He told Mike that, asked me to come do this. And I also want to thank several other people in the FAA, Lance Gant and Wes Ryan, who helped put together for the FAA panel, and Dr. Theodore from NASA Ames, who helped me get the NASA support, and appreciate all their help in getting this panel together. And first thing we probably want to cover is what's the motivation. And Mike can tell you that, and if you've been watching the AHS pages on their website, you've seen a lot about the eVTOL, which was one of the major motivators for this presentation. And what we want to do is kind of address some historical aspects and then address where we're going. And that's the reason I had to get a lot of support from the FAA to get this presentation together, because a lot of it is changing rapidly. And for the FAA, you'll see how fast things are changing to be able to address the issues that we know are coming. And some of them are already here, okay? And this is just to highlight a few. Obviously, most of you are aware of the Uber Elevate air taxi, basically a challenge. You're aware now of all the electric aircraft projects that are going on. Some of them are hybrid. Some of them are going to be conventional power plants, because there's more than just the inner city projects that are going on. I think last week at Uber Elevation, they said there were 74 companies developing aircraft to meet some of these programs. Obviously, they all won't make it. The concern for this presentation is that at least 50 of those companies that are now participating have probably never done manned flight before. All right, and a lot of them come out of the UAV, some of them are out of the IT world. There's a lot of other companies involved that have not necessarily gone through an FAA process or a military process to certify an aircraft. So that's part of our motivation. Historically, for civil aircraft, those in the OEMs and those who dealt with rotorcraft certification are very familiar with the Part 27. There's a lot of presentations in some of the different sessions about the normal category aircraft. For our discussion today, I'm not going to talk about transport category because that's the larger aircraft. We're going to basically stay with the light aircraft because almost all the projects I've seen are in that 4,000 to 7,000 pound range, which is going to put them in this category. Historically, in fact, a lot of people don't realize that gyroplanes are covered in Part 27. So if you've got a gyroplane that's certified, that's where it would have been certified. In the safety meeting today, I heard a very good presentation on 2117B. Prior to this 2117B, the tilt rotor, and I went ahead and put all the abbreviations it's had for the 609 since it's concept. That project started back in 1996. And it got its first G1 issue paper, which the FAA sets the cert basis in '98. And hopefully they'll certify, I think was said today, in next year. So that's the plan. It takes a long time. And the 2117B, from a very simple-minded point of view, says take all the existing rules for small aircraft, transport airplanes, small helicopters, big helicopters, even hot air balloons if it's appropriate. You pick the rules that exist, that apply to the design, and if there's something in the design that doesn't have a rule that's appropriate, you have to write that rule, and that took a long time to develop. A lot of people don't realize that's the rule that's used for gliders, and then they publish the cert basis as an AC. Same thing for airships. And then traditionally, the engines on all these aircraft are certified under a separate rule, and they have their own type certificate. So that's under Part 33. This is the way it's been done for the civil side. And when we have our Army presentations, they'll talk about some of the certification on the military side. But But things are changing. There's been a lot of change here recently. Those who worked the Part 27 helicopters are probably very familiar with the policy change that came out here, I think it was just last year. And for the first time, they took the Part 27 helicopters and broke them into 4 separate classes. 23 has had something like this for a good while for the small airplanes, but it didn't exist in the 27. So this breaks it down so that a Robinson doesn't have to meet the same requirements as, say, a Bell 429, which is a twin engine right at the max weight. So these now have 4 classes, and their reliability standards that they must meet are now based on the exposure and the size of those aircraft. Everyone working in the eVTOL is very familiar with the Amendment 64. What they may not realize is that that took almost 10 years to get that amendment through the rulemaking process. So from 62, which is where they started in 2007, till the time it was published, it took almost 10 years. That's a lot of change. And what it did is it took all these prescriptive things that said you must do this in your design, took that out, and is now very much more generic, but it placed the requirement to put that in a consensus standards. And the ASTM is one of the major ones, and Gamma has, I think it's Committee 44, that has helped write those standards. And there was just a meeting last month to bring that. They meet like twice a year, I think, formally. And last month they had a meeting in Cologne, Germany, and that's an international standards. What some of the new people to the business may not realize is that's great to have the standard, but until the FAA issues a letter of acceptance, then that's still not, you still can't use it as a means of compliance in and of itself. You can propose it, and then it has to go through a process. So, but that's a big change. And depends on who you talk to. The 23 covers probably about 80% of these VTOL design. It covers rules that would meet about 80% of the requirements for the airworthiness requirements. Also, one of the things we're finding out is, those people who've been in the unmanned world for a long time, the UAs, the RPVs, whatever acronym you've known it as, it's been going on now for about 30 years, and that's why our first presentation will be talking about some of that. But most of these new aircraft designs are doing a lot of proof of concept by building small models, subscale and now up to scale. And they're flying them unmanned, and some of them are being designed from the get-go as they're full autonomous, so they can program it to do what it's going to do. Because of that, and because they haven't necessarily, these companies haven't necessarily been in the manned aviation world, not sure they fully understand some of the risk management that needs to be considered in that, and so we're going to be talking about some of that. A lot of the companies obviously are new to the airworthiness requirements of the FAA or EASA or whoever else, wherever they're going to try to certify their aircraft. All the rules are not standardized around the world, but they pretty much follow the same kind of requirements regardless where you go. Sometimes the means of compliance in order to show compliance to those rules is different around the world, but the rules pretty much read the same. And as I said, risk management is a whole different ballgame, building a little subscale model and flying an RC in your backyard and building that up and then doing experimental flight tests where you've got a lot more liability involved. And so some of the companies that are making these aircraft have not experienced those things yet. And we know we have designs that are everywhere from barely on paper to been flying, some of them been flying for 5 or 6 years. So there's a lot of development involved, but they still haven't come to the formal certification process yet, even though a lot of them are talking to the FAA. So that's the motivation for why we have this panel. I do have to say on the initial program, you saw we had a Gamma representative, and he had to stay in Washington, so he couldn't come today. He was going to address some of the ASTM and the consensus standards for means of compliance. that we were going to talk about, but the FAA is going to work some of that into their presentation, so hopefully we can catch all that. We're going to start off our panel members with Michael Olson. As I've said, the Army's been in this business for over 30 years, working with unmanned aircraft. And Major Olson is an experimental test pilot with the U.S. Army Aviation and Missile Research Development and Engineering Center, and is the program manager for the Aviation Development Directorate's Next Generation UAS Technology Demonstrator. He earned his Bachelor of Science degree in Mechanical Engineering from the University of Central Florida and was commissioned as Second Lieutenant in Aviation. He holds a Master's degree in Aerospace Engineering from Georgia Tech, Georgia Institute of Technology, and is a graduate of the U.S. Navy Test Pilot School. He's a Master Army Aviator with over 2,300 flight hours and 18 years of military service. His research and development experience includes evaluation of aircraft performance, handling qualities, software, human factors, and mission equipment. His previous assignments, he included as an Aero Scout platoon leader, an operations officer, troop commander, and logistics officer for the cavalry and the 101st and of the 10th Mountain Division, as well as an attack UAS division chief, Apache account manager for the Redstone Test Center. So, Major Olson, start our presentation.
So thank you for coming, and thanks for the invitation as well and the opportunity to participate. So again, I'm Major Osmon. I work for the Aviation Missile Research Development Engineering Center. A couple slides just on the organization. This is our mission. We are capabilities focused, so I know we get wrapped up a lot in the technologies on our S&T side, but it's the capability we're after, just enabled by technology. So this is who AmberTech is. You can see the core competencies on the right and the workforce breakout. It's headquartered in Huntsville. It's got 5 directorates, which are geographically dispersed. The directorate I am in is the Aviation Development Directorate. And I'll just highlight that most of those military members are located at Fort Eustis supporting pilots and non-commissioned officers supporting the flight test activities there. These are the 3 AmberTech priorities under the new director, Dr. Harris. And then within the Aviation Development Directorate, I just wanted to touch on some of our key focus areas. We're functionally aligned within these technical areas. We do have additional major program areas in order to execute the portfolio. And there is one activity, one Air S&T portfolio in the Army. It's led by the Aviation Development Directorate. So as far as the actual agenda, Dr. Lewis also appointed me for this panel. And really what he requested and what his focus was try to talk about how a commercial vendor, with all this activity going on in the unmanned or advanced VTOL configurations, how could they use a government process to facilitate a test or a demonstration, really including or focused on qualification credit that would also benefit the government. So as I kind of went through that to deconstruct that, there was a variety of factors that shaped those potential options and what that could look like. So the key discussion items, kind of the agenda that I plan to tackle, you can see there. I've got a lot of slides. Some of them are text heavy. I'm not going to spend a lot of time on necessarily all of them, but this should be available for other reference post forum as well. And I'll say that it does seem, this is prefaced in the context a lot of what Rick introduced. It seems to me that there's a wide landscape of various activities in advanced VTOL, and that the shift may be away from the traditional government-led or government-pushed to more commercial development with this first-to-market type of efforts taking place. So I know there's a variety of experience in the room. I'm not going to belabor each point, and really it's introducing some concepts that may facilitate discussion later. So some of the underlying factors, as I tried to really set out, it would have been nice if I could have just gone and laid out a flow chart, process flow chart to go in. You enter here, go through these steps, and that's what would get us into some government facilitated test or demonstration, and addressing some of the elements for qualification. But with all of the various factors, these to me are some of the essential ones, and it's not really a flow chart, but it's the things that would need to get addressed to really figure out what that could look like. So some of the first questions, and this is really from a test or a demonstration planning perspective, so I know there's a lot of other factors which most of these other panel members will speak to. So the first one, right, is what is a certification objective? If you want to execute a test or a demonstration and receive qualification credit, you need to know what you're headed towards. So military or civil, and if it's military, is there a specific DoD component that you're expecting to pursue? Airworthiness qualification level. This may make less sense in terms of if you're going straight civil, but in the Army, Stephan will highlight some of the differences in airworthiness qualification levels. Man standards, obviously more stringent. Something less, well, we have Army qualification levels 2 or 3. And both of those to me really speak to, again, is what are, if you're speaking towards qualification credit, what are the standards you're pursuing? What types of data are you going to need? Looking at, again, the level of substantiation you're trying to collect the data for, which may dictate the number of test points, the kind of test points, and how many of those things, again, could be applied towards that future qualification. Ownership, right? Is this a government-owned or released platform? Is there an opportunity for government sponsorship where it could be, and I'll get to that in a little bit of what some of those relationships may look like, where it's still owned by the company, but there's a government interest or sponsorship in it, or is it inherently and independently a separate commercial activity completely? Aircraft control, alluded to some of it. There's pros and cons of if there's a pilot on board. Traditionally, that could be seen as a risk mitigator. He's there to take over control. Sometimes it's inherently dangerous then as far as you go through the hazard planning and risk assessment. I know there's a lot of flight testers in the room that can speak to that too. Remote piloted, is it fully autonomous as we get into that with software and critical software systems? And then lastly, what are the actual vehicle attributes? A test or a demonstration including a 400-pound UAS, it may look significantly different than a 4,000-pound unmanned aircraft. So weight, speed, some of that is, again, just a risk mitigation, risk assessment, and planning. The STANAGs have some delineation in there on weights and energy, right? How fast is it going? How heavy does it weigh? That may play into, again, the risk to those non-participant individuals on the ground that were out mowing their yard and had something come down on them, right? Endurance, again, test planning. Am I going to have to worry about this flying 2 states away as far as a risk mitigation or control measure type of approach? So to me, all of that to combine, cover-all process template is difficult to outline on a single slide. Particularly, I think that's where a lot of the conversation will go today, and it, to me, requires the case-by-case assessment based on the interest of the people who own the vehicle, as well as any government involvement, what our interests are. So just to facilitate kind of discussion, a little bit of my mindset moving forward, kind of assuming this, blurring the lines a bit between the civil and the military specific aspects, but assuming, again, this kind of eVTOL concept towards air taxi type of implementation, that you'd be pursuing a civil certificate, man standards, to talk to the test demonstration, that there would be some government sponsorship available. Generally remote piloted, but with some semi-autonomous functionality and kind of towards the top end or above the Group 3 threshold for unmanned systems. So I'm not going to speak to all of these, but as far as if it's a government sponsorship or participation between government and industry, then these are some of the instruments available to allow that cooperation. So everything from the commercial or procurement contracts, FAR-based contracts, fixed price, cost plus type contracts, through cooperative agreements and other transaction authorities. Example there, what's going on with the Joint Multi-Role Technology Demonstrators as a technology investment agreement. There is cost share expected and or required as part of that, and you can see some of the other delineations. The one I'll touch on a little bit more is this no-cost loan demonstration agreement. Some personal experience with that, but to me that's one of the relatively low overhead opportunities to facilitate that could meet a variety of objectives, both on the OEM or the commercial interest and on the government side as well. So the example there from our 2016 flight trials, we had a no-cost agreement with Airbus where they brought their Spherion system, but again, relatively simple and straightforward agreement. It involves some scope and responsibility definitions, but allowed us to sponsor and host that demonstration. Aside from Airbus, it also allowed some UK and Canadian research entities to come in. So we, the government, paid for the range. We hosted the event. We provided an overarching test plan that they participated underneath. We provided fuel and facilities. They were responsible to get their asset to the test site to comply with the test site rules, which I'll touch on later as far as some potential test locations on the government side. We got the opportunity to see their demonstration, to receive their technical report. We had the discussion, the dialogue, the cooperation there, and officially no money changed hands through that. And again, it was relatively straightforward and kind of a win-win situation. Other traditional things there you can see there, cooperative research development agreement, other test services agreement with some limitations on each of those as well. I would say that that kind of level of government sponsorship, though, would imply that we are either interested just for the simple aspect of technology advancement or that there's some explicit military utility involved. So getting into a little bit of the flight test risk assessment. So flight test safety risks are really a fallout of identified functional operational hazards. So identified there is in red. Obviously, you can't try to mitigate something if you don't account for it. Some of the other safety presentations today, we're talking through methods to go through that, but functional hazards are an airworthiness authority responsibility. Again, that will be covered mostly by Dave Stephan here next to me. Operational hazards, range commander's responsibility, governing regulations for both of those, and just highlighting again, thinking towards and planning towards a flight test event. Everyone's a safety officer. You really have to have the participation of those individuals who are smart on the systems and subsystems, who know their areas of expertise and disciplines in order to account for the hazards associated with those failures effects are in order to achieve that mitigation. So risk assessment and acceptance are the system owner's responsibility at the appropriate level. So those are specified on the government side by the appropriate regulations as far as which level of authority can accept what kind of risk. Just the two standards that we use most frequently, MIL Standard 882E, right, which is the system safety manual. It's the DoD's approach for identifying hazards and assessing and mitigating the associated risks. Not on the slide is also another Army regulation, 385-16, for system safety, engineering, and management, which applies to all Army systems and facilities. So I just want to highlight those. Those are our guiding documents within each level of kind of unit, flight test activities, test plans, activities. Those are the documents referenced, and they get into great detail on how to go through each of those. So one of those details is this example of a hazard, elements of a hazard matrix. Gets into kind of the methodology there on the left, going through, right, hazard category, hazard element. Again, I'll highlight that the knowledge of the system is essential. You can't do this without basic system description, knowing that the vehicle that you're going to perform the testing on, and the thorough understanding of the systems. So being able to assess what the severity, probability are for those hazards to identify ultimately the initial, and then based on the mitigations that you can apply. And there are, the manuals talk through what are the steps what is the proper kind of order of precedence for mitigating those hazards. And then the bottom one I just wanted to highlight again, as these systems become more safety critical, 882E also has that software criticality assessment aspect and gets into the levels of rigor for software verification and assessment, the depth and breadth required to actually guarantee a certain level of safety. Just wanted to include a risk assessment example. To me, the one difference, often through manned platform risk assessment, you end up with an initial severity category. So that's the highest likelihood of death to occupants or severe injury. There's a dollar threshold as well for Cat 1 above $10 million. So typically if there's a person on board, it gets really difficult to mitigate that to actually reduce the severity if there is an incident. But unmanned aircraft, it's a little more likely or easier to mitigate that down to a reduced severity if there is an incident. Some of this was pulled out from our local kind of test planning handbooks. So to me, just want to highlight the difference between a fundamental, more system-based total system towards certification and something more directly towards a flight test activity, flight test airworthiness release. So a test airworthiness release may be essential to enable the flight test activity. So it's going to reference things like a flight test plan, which gets into the detail of test, method of test, which may be part of the specific test procedures. But what is the scope? What are the assets involved? And how are you going to accomplish that test? Identifies the testing personnel, any specific flight envelope limitations that may be beyond the actual handcraft or handbook, operator handbook, or other existing limitations, or it may be smaller based on the scope of the test. It may identify special inspections, load and stress limits, and it may also stipulate other requirements prior to flight tests in order to actually provide some of the necessary substantiation, again, guaranteeing safety. To switch a little bit, again, part of what Rick asked me to touch on was if you're gonna pursue this, who should you talk to? What kind of information would you need? Where could you conduct these type of activities? So wanted to highlight what are called major range and test facility bases, or MRTFBs. The ones in red are the Army Test and Evaluation Command facilities. And again, Yuma Proving Ground is the one that I have most direct experience with. So I just want to highlight a couple things out of the DODI as well, that all of those MRTFBs are authorized to use resources by commercial entities. So again, that aspect of if you are a commercial entity that have no interest in pairing with the government to do a flight test, to provide us information and allow us opportunity to provide oversight and accomplish things together, you can still approach any of these facilities on your own and offer to buy the range space. They'll still coordinate with you. In the interest of time, I'll just move to this is what you'd be signing up for. Each MRTFB user is still going to have to provide information to the test facilities there in order to confirm, again, that you're going to be able to conduct things safely and within the restrictions that they have in place. It's going to identify or require any identification of any unique test support capabilities. Of course, again, the paying for the facilities, that's one of the benefits, again, of either government sponsorship. You would get the special government rate, as it were, to conduct that, and or in that test agreement, the government may end up paying part of that bill. So again, these are there for future reference. Example, Yuma Proving Grounds has a, so if you show up there, right, assuming an unmanned system, they have their SOP that dictates all operations on the ranges, and as part of that, they have their specific UAS operations on YPG ranges. So you'd have to comply with all of that. They have a safety assessment which gets into UAS-specific hazards over time and experience that they have there, and there are standard mitigations addressing kind of all those, again, standard hazard areas. The safety assessment includes just the background information on the UAS itself, talking through those potential causes of vehicle loss of control, common safeguards, emergency procedures, and accounting for the possibility of any mid-air collision hazards either on or off the range. Payloads we didn't talk about very much. A lot of Army UAS have specific payloads that emit things, so that's also a part of test planning and risk mitigation. That's the final slide. Again, I added some other backup slides, assuming that these will make their way out. You can reference them in the future if desired. Otherwise, I'll be followed by Dave.
Thank you. All right. Our next speaker will be David Stephan. And I will mention that I'm reading the bios for a good reason. And part of that is that I think you need to understand the expertise or the background of some of our speakers, because that adds validity to what they're saying. And for future reference, if you do need to contact them, I think you need to know their background. So I'm trying to keep it as short as I can, but make sure you understand who we have on the panel and their subject area. Dave is currently the Associate Director of the Technology for Technology, responsible for all functional engineering within the Army Aviation Engineering Directorate. He previously served as the Acting Director for the Aviation Engineering Directorate on 2 separate occasions. In addition to this, he's had positions of Tech Director, Apache Division Chief, Armed Reconnaissance Helicopter Branch Chief, and Team Lead, Apache Team Lead, and Systems Engineering, and Apache Systems Engineer. He also supported the PEO, which is a Program Executive Office. That's what I forgot all that. I've been retired too long. For the PEO, Aviation for Non-Standard Rotary Wing Project Office, leading the OH-58 Foreign Military Sales, and Iraqi 407 support as a developmental assignment, and has experience as an engineer within the PEO Aviation Apache Program Manager's Office, supporting weapons integration and testing. He has a bachelor's degree in engineering from the University of Missouri in Rolla, now the Missouri University of Science and Technology, and an MBA from Southern Illinois University. He is a member of the Army Acquisition Corps and a Level 3 certified as Systems Planning, Research, Development, and Engineering. Dave?
I probably shouldn't have provided all that information, so I'm going to cover Mike mentioned a few areas that of airworthiness that they work on in ADD. They do a lot of development work there, but we're the Army's Delegated Aviation Airworthiness Authority for fielded systems. So the actual Airworthiness Authority for the Army is Major General Doug Gabram. He's the commander of the Aviation Missile Command, and he delegates his authority to a number of individuals, including the Aviation Development Directorate, Mike's home organization, for some flight controls research work and some development efforts. One of the guys in our office calls them the Orange County Chopper folks. They do some rapid development work for some quick capability initiated into the field. The enabling policy that we that we follow, as I mentioned, was AR 7062, and there's a number of SOPs and aeronautical design standards that we follow. So as I said, we're the delegated Airworthiness Authority for all fielded systems. That includes all the major weapon systems that the Army has, including, you know, the systems Apache, Black Hawk, Chinook, and also some special operations aircraft. We also manage the airworthiness for both MH-60 and the MH-47 fleet. The thing I'm going to talk about today, though, is mainly about the airworthiness piece supporting unmanned systems. And one of the things that we always talk about when we go through the airworthiness process is the 3 pillars that we all follow. And most of the effort that we talk about is all on the left side on the design phase. And that's where we develop our AQP, Airworthiness Qualification Plan. And all those requirements can be hundreds of pages with several reference documents of hundreds of pages each that we put out to our our contractors and ask them to interpret what we intended when we put these plans together. And I'll talk about that a little bit later. But the other piece that's part of airworthiness is the aircraft that there's going to be produced in accordance with that plan after we've gone through testing. Is it the same as what that was tested? And that's led to some problems recently and throughout history because a lot of times the production aircraft don't seem to match exactly what was originally tested. And then the final piece is the continuing airworthiness piece, the maintenance manuals, all the inspection intervals, everything that needs to be done, including training of the maintainers. So within the Army, this is the standard airworthiness process. This is both for manned and unmanned platforms, but we don't do anything without funding from a program office. We don't go out and look for business. In fact, you know, we've had people contact us and they ask us for an airworthiness qualification plan for a system they're trying to sell to a foreign government that has not in the current U.S. Army fleet, or try to get ahead of the game before the Army comes out with a requirement and they want to know what the requirements are going to be. We're not allowed to do any of that work without support from a program office, and they have to have a validated requirement. So what we do is we get that requirement from the program office, we develop an airworthiness qualification plan, and what comes back is we coordinate that and give that to a original equipment manufacturer, and they develop an AQS. Some people say that's backwards. You guys should put the AQS out and they develop a plan, but this is the Army's regulated process. And we'll negotiate with the OEM to come up with that airworthiness qualification specification that's going to go out and they're going to go do the testing against. They'll develop all the components and component test plans, subsystem plans, system plans, complete a lot of that work historically directly, and then write the reports, submit that to us for approval, and in many instances in the past we would throw it back and say, well, you didn't collect what we wanted. That's not how we have to do business in the future. So one of the things I'm going to talk about at the end is a little bit of where we're going on future vertical lift as far as airworthiness plans and what the current status of some updates are for some of our requirements documents. So the purpose of this briefing, as I talked, was some of the UAS pieces and what we currently do and what we don't do as far as airworthiness. As you see, this is a kind of a graphical description of the different categories, level 1, 2, and 3, for each of our systems. Now, level 1 is essentially the same as a manned platform. We would require the same effort that we would for any, say, FAR Part 23 aircraft. So the Army only has right now in their programs of record just fixed wing platforms. So that's why it's Part 23, but it would follow the same process for a Part 27 if it was a rotary winged aircraft. But basically, what we require is if you're gonna do something significant, such as a weaponization of a platform, you need to have at least airworthiness qualification level 2. That's been our policy for 2 years. So these aircraft have been out there for many, many years, since early in 2000s to support the war on terror and different efforts, but we never got anything into regulation until 2016. So we've been working off of some internal documents. And when we put these out, you'll see that some of the requirements are greater than what the aircraft meet for any level. So, but anyway, the risk, essentially what we do is level 2 and level 3 are risk-based approaches that the Army follows. Level 2 means you've got some level of data, and what we have on our Gray Eagle platform is we have qualified the kill chain from the sensor to the data transfer to make sure that if anything goes to another platform that isn't verified, it all meets the Army certification requirements. And level 3, as I mentioned, essentially they range. So Gray Eagle has done a lot of work. We've had a lot of systems that have done a lot of qualification work, but they don't meet all the requirements. Essentially, you know, these are treated as expendable aircraft, and that's hard to do for a $10 million aircraft. So it's, you know, when you don't design things with airworthiness in mind because of necessity, then that you have to live with the details. So from a level of airworthiness requirement, this is just a graphical depiction of some of our requirements from a level 3, and it just shows that we get minimal data for a level 3 AWR, and it grows rapidly until you get to the level 1 manned requirement. And when we go forward with our new future UAS system, it's expected that it's going to be a level 1 requirement. It's going to have to meet the manned requirements. So, as I mentioned, some of the current UASs that we have, they were developed as programs of need to meet some capability that the Army had in the field. So they weren't designed with airworthiness in mind, and we had to figure out how we would support them. So you'll see some of the restrictions that we have in most of our releases that talk about restricts flight over populated area. We limit lots of things from exposure standpoint. So, and we put a lot of cautions, notes, warnings about the systems that are on the aircraft that don't meet those airworthiness requirements. As Mike mentioned earlier, each of our systems has gone through a safety hazard review, and we've reviewed all those and included any limitations into our airworthiness releases that we provide to our field. As I mentioned, we'll never get there with some of our current fleet as far as a certification level. They weren't designed with that as part of their original design. They're doing the best they can, but that's as good as they're going to get. And they meet the intent, which was to put a capability in a tactical environment that meets the Army's needs. So the problem came when we decided to bring some of those aircraft back here and try to do training here in the States, and then try to figure out how we do that with an unqualified system. So that's where all the hazard analysis came into a lot of detailed reviews. And the way we manage this in order to fly these aircraft in the United States right now is through a casualty expectation model. So we review the current reliability data that we have on each of these platforms, compare that to the planned test flight route and the population densities in the areas that we're trying to fly. We'll come up with a figure and try to minimize that as much as possible while still meeting test requirements. But that's the way it's handled right now. And in fact, in some instances, we're doing the same thing in foreign territories. So from a risk standpoint, the risk for each of these systems is accepted at multiple levels. From a material standpoint, there's a lot of things that weren't developed to the proper standards, and there's some things that are accepted by the material developer. But as I said, these aircraft were not fielded with the intent of flying them in the United States airspace. So if we're going to operate them anywhere outside of a tactical environment, we need to get the operational risk accepted by the appropriate authorities. And we usually, that's usually the first general officer in the chain of the activity that's conducting testing. So we do the best we can, but this is not the way that we should be working our unmanned systems efforts. So this is kind of a, hey, this is what we've done in the past. We've got a lot of lessons learned, and we need to design to the right requirements. So a few years ago, OSD funded some work between all the three services. And from a fixed wing standpoint, Mill Handbook 516 contains all the qualification requirements for our unmanned platforms from a fixed wing standpoint, as I said. But it doesn't do a great job on rotary wing. So we have several folks in our organization that have been leading a lot of the NATO standardization efforts. We've got several of these STANAGs that are listed here. The one that's probably of most interest right now is the 4746, and there's a draft standard. I think it's AEP 89 that's being reviewed right now for approval. But that's where we are. There's been a lot of effort put into this area, but we know that industry is going faster than we are, and we're going to rely on you to help us define some of those standards to help qualify these new systems, because I know when the Army sees the capability that is being developed across the commercial industry, that we're going to need and want to use that capability in ways you probably never imagined, but will certainly help us as a nation. So that's really the only information I've got on the UAS piece. Just try to give you up to speed on where we have been and where we're going. From a future vertical lift standpoint, I want you to know that we're currently working on some new standards that are similar to a mill handbook 516. So it's going to contain all of our rotary wing standards. It's called an AMAC, Army Military Awareness Certification Criteria. So if you're tracking what the Europeans have done, theirs are the EMACs. So we just kind of copied off of that, but it's based on 516 that the Air Force has done. So we're developing that right now. And we've learned a lot through some of the efforts that have been ongoing with the GMR technology demonstrators and with both the Bell aircraft and the Sikorsky Boeing defined aircraft too. So we have some folks that are working directly with those teams, specifically people on site witnessing flight tests, participating. But the biggest thing that we've done on that effort is because the Army only funded about between 25 and 30% of those aircraft efforts, is we've allowed both those vendors to use their own internal processes for airworthiness. They're flying under experimental flight certificates. They're going to be flying in the Sikorsky Boeing sake. And we're gaining confidence in what they've been doing because they've done it many times in the commercial world. And our goal is to become as only military as necessary. We need to get our standards to the point where when you look at them, they're very similar to the civil requirements. So our expectation for future vertical lift is we're going to issue a military type certificate, not an airworthiness release, and along with the type certificate data sheets and a tail number airworthiness certificate of airworthiness, to try to get more in line with what industry is doing, because we really need to get there. We've been confused in how we've done some of this stuff in the past, at least confused industry on how the Army does business. And I think this will give us more opportunities to collaborate and improve the way we do business. So that's all I've got. Thank you.
Can't get there. Okay. Thank you very much, Dave. And we'll move now from the Army side to a lot of things that are kind of in between the military certification and the FAA certification. There's always research. And in between, we got NASA. So representing NASA today, we have Dr. Paula Dempsey. Dr. Dempsey is currently serving as the Deputy Program Manager for the Revolutionary Vertical Lift Technology, or the RVLT, project under the NASA Aeronautical Research Mission Directorate. The RVLT project goals are to develop and validate tools, technologies, and concepts to overcome the key barriers for vertical lift vehicles. The RVLT project is about a $20 million project supported by 67 researchers across 3 NASA centers of Glenn, Langley, and Ames. Prior to this, she spent 18 years as a researcher focused on the development of diagnostic and prognostic tools to assess the health and remaining useful life of dynamic mechanical airspace components, mainly in the rotorcraft propulsion systems. Dr. Dempsey has authored over 45 technical presentations in this field, and her research fed condition-based maintenance design standards for military and civilian rotorcraft. She supported the AHS International's Health and Usage Monitoring Technical Leadership Committee, the U.S. Army Condition-Based Maintenance Working Group, and is a technical researcher for several journals, reviewer for several journals. NASA has recognized her contributions with an honor award for exceptional engineering achievement. Throughout her 27 years of the NASA career, she has had the opportunity to serve as a project manager and technical lead for various interagency NASA programs and led collaborative projects for academia, industry, and the Department of Defense and FAA and the National Renewable Energy Lab. Paula's educational background includes a bachelor's degree in mechanical engineering, a master's degree in industrial engineering, and a doctorate degree in engineering science, awarded by 3 Ohio universities. She is recognized by the state of Ohio as a STEM exemplar. And Dr. Dempsey, please welcome.
All right, my bio, I think, is longer than my presentation. He asked for a page, and I gave him a page. So anyways, thank you for coming and learning about how NASA contributes to certification. When Rick first invited us to come, he asked us a question to answer in our briefing. How does NASA help transition from a vehicle computer design to prototype flight test to production representative aircraft? Well, NASA's role is really to support standards development, to address certification needs, and also develop tools for the community to use in vehicle design. So the certification path that I'm sure my friends from the FAA are going to talk about crosses over several areas, operations and airspace requirements. On the vehicle side, certification regulations based on standards and means of compliance, and also crew qualification requirements. I'm just going to focus on the vehicle certification regulations, standards, and means of compliance in my presentation. Now, for those of you that aren't familiar with some of the deliverables that NASA provides to the community as part of their research, we typically work to technology readiness levels TRL 1 to 5, sometimes 6. Well, what does that mean? 5 is a component validation in a relevant environment, and 6 is when you have a system or subsystem that you demonstrate in an operational environment. Not until you get to like TRL 8 is it a flight qualified system. Typically what we produce are feasibility studies, technology demos, and research reports. But what we find is if we partner with DoD or industry, we can transition our technology to the community faster. So I'm going to just give you a little bit of background on the Revolutionary Vertical Lift Technology Project. The goal is to develop and validate tools, technologies, and concepts to overcome key barriers for vertical lift vehicles. Our scope is very broad. We look at technologies that address noise, speed, mobility, payload, efficiency, environment, and safety, and both conventional and non-conventional vertical lift configurations. And so I'm going to highlight some areas that we support in the vehicle certification in acoustics, crashworthiness, electro propulsion, and conceptual design. So first let me talk a little about acoustics. The researchers in our project, they develop tools and validate tools for noise modeling and annoyance modeling. So one area is they perform psychoacoustic tests and assessments for human community response, trying to establish annoyance metrics. What we find is it's not just loudness. There's a lot of other components to the annoyance to different noise. And if you look at that photo on the left-hand side, it shows an exterior effects room. This facility is located at NASA Langley, and what they do is they have different sounds from different vehicles that they expose human test subjects to, and they get them to assess their level of annoyance. In addition to that, the researchers perform source noise modeling and tool validation, both in laboratory measurements of propellers, electric motors, and also field tests, where we fly aircraft and are able to take measurements on the ground. Another area is looking at optimal trajectories and operational models and tools for low noise operations. So a lot of the work has been done in providing to the community, and mainly pilots, how to fly the vehicle quieter in certain environments based on how they operate the vehicle. Some of the folks developed training courses for the Helicopter Associate International to educate the pilots. In addition to that, a newer area is fleet noise modeling for community noise assessments, not just having one vehicle, but if you're looking at the future advanced VTOL kind of urban air mobility concept, if you have a lot of vehicles in an urban environment, how does that affect noise to the folks on the ground? All of these pieces eventually feed into developing noise metrics to support certification standards. In the past, a lot of the standards were Part 36, helicopter noise standards, as this new vehicle class evolves, those standards may change. Okay, the other area is in crashworthiness and survivability. I don't know if you had the opportunity, but there was a crash safety session yesterday, and there was a presentation that I would recommend if you're interested in this area to get from your proceedings. It included looking at bird impact testing on rotor blades. There's been a lot of work done to the point that we have an artificial bird that's accepted for certification and testing. It feeds into SAE standard G28, simulates for impact and ingestion testing. And if you look at the bottom, there's kind of a politically correct picture of the, the bird impact testing. A lot of our folks participate in standards committees and other type of committees. One area is the Aviation Rulemaking and Advisory Committee for Transport Aircraft Crashworthiness and Ditching Working Group. And what that working group does, it provides recommendations to the FAA for transport airframe level crash and ditching requirements, and it feeds Part 27.562, Emergency Landing Dynamic Conditions. Okay, the other area is developing crashworthiness characteristics for airframes. There's vertical drop tests of barrel sections with test dummies that are performed at NASA Langley. They have a large gantry. It's called the Landing Impact Research Facility, where they can take a fuselage and put some test dummies in there and instrument them and gather a lot of the information. And this data is provided for the Aviation Rulemaking Advisory Committee to validate models. Okay, a new area that we're starting to work in is electro propulsion. And electro propulsion for vertical lift vehicles, we're trying to understand what kind of information would be required to certify these types of systems. And we have been generously given some of these standards from the FAA. Gary, who's going to chat after I am, he is looking, he's working on standard practice for design and manufacture of electro propulsion units for general aviation, ASTM standard F3905, as kind of a baseline for certifying these types of systems. And he gave us the opportunity to review and provide inputs into that standard, and we're also working different research areas that hopefully will be able to support development of certification needs for electro propulsion systems and urban air mobility vehicles. And one of these areas is tools to perform urban air mobility propulsion parametric sensitivity studies. We have some folks at NASA Glenn that are looking at MPSS, which is a propulsion software that's used for engines, and they're providing new modules to look at electric components and electrified aircraft. And then another area is, another project is the Flight Demonstration and Capabilities Project. This is another project under the NASA Aeronautics and Research Mission Directorate. Many of you have probably seen articles or other information on the X-57 Maxwell. That's where this project resides. A lot of lessons learned from this all-electric vehicle, in the integration and flight test of this vehicle. This information is being fed into ASTM standard F3905, which I just mentioned, and F44, general aviation aircraft. We're also working with them to develop NASA design guidelines for safe high power voltage batteries, and with our NASA Engineering Safety Center. Okay, last but not least is conceptual design. We have some conceptual design gurus that support our project, and they actually put on a course on Monday. If anyone had the opportunity to attend this course, you probably saw some of these vehicles because they went through some of the analysis with them. When we first started trying to get our arms around the technology and missions for the urban air mobility market, there was just so many configurations and so many infinite possibilities that we had to try to kind of constrain the problem a little bit so that we can assess, do different parametric studies, different trait studies on these different concepts to understand which technologies work best for different configurations. So our conceptual designers, they developed these three configurations. One's you can see them right there, a multi-rotor and a tilt wing and a side-by-side. And then they went through the whole conceptual design process, looking at different propulsion architectures and different capabilities within these different vehicle classes. What this did was allow us to look at a wide range of technologies and missions and provide some focus for our trade studies. And what we're also going to do is look at the propulsion architectures of these 3 different concept vehicles, and we're going to be able to assess the failures and hazards and go through a failure modes and effects criticality analysis to try to identify how do they fail, which areas do we need to focus some of our attention where there's a lot of unknowns that need to be further understood, such as like durability, reliability, maintainability of these different architectures. If you're interested at the bottom, it shows the citation for the reference. It was presented at the AHS conference in January, Aeromechanics Design for a Transformative Vertical Lift. Okay, the last thing that Rick asked me to do was to provide point of contact for the different areas. So the different parts of the certification that I presented, or the technology that feed into the different certification standards for acoustics and crashworthiness and electro propulsion, and also conceptual design. Susan Gordon is the point of contact, and she's the project manager for the Revolutionary Vertical Lift Technology Project. And this is her email. And for the X-57 project and other flight tests that are performed at NASA Armstrong Research Center, it's Brent Cobley. He's the project manager for Flight Demonstrations and Capabilities Project. And that's all I have. So thank you very much.
And we will be taking a break with the rest of the group so we can stay in those time frames. So when you do take your break, please bring all your colleagues and friends back in, so we'll come back in 4 o'clock. I think we have one more time for one more presentation before we do our schedule for the break. So we'll start our FAA presentations. And you see how some of this starts going between all these different organizations. There's a lot of work that's been going on for a long time and a lot of collaboration, and it's beginning to show. Our next speaker is going to be David Weber, and David is currently working as the flight test engineer and program manager in Kansas City supporting small aircraft standards branch. He is involved in a variety of research and pre-application projects, which means he's talking to some of these VTOL designers and corporations in order to support the regulatory policy development of new and novel aircraft and general aviation modernization. An aerospace engineer, experienced aircraft builder, and instrument-rated pilot, David started his career at Edwards Air Force Base, where he worked as an Air Force civilian and performance and handling qualities engineer and test conductor for the X-31, which was the enhanced fighter maneuverability demonstrator at NASA's Dryden Flight Research Center, which is now Armstrong. At the completion of the X-31 program, David transitioned to NASA after a short stint as a B-2 flight test engineer. As a NASA operations engineer, David worked all phases of research projects as a flight test engineer, test conductor, and flight crew member on the F-18 Systems Research Aircraft and the DC-8 Airborne Laboratory. In 2003, David, who had, as his 2 children approached school age, he escaped the Antelope Valley and relocated to the Pacific Northwest, where he worked as a certification flight test engineer for the FAA's Seattle Aircraft Certification Office. In Seattle, he supported many domestic and international fixed-wing and special class aircraft certification projects. Always intrigued by the new and novel technology, Dave transferred to Kansas City in October of 2016 in order to actively be involved in the facilitating of the emerging small aircraft technologies. And these, I'm going to read this word for word, Dave. This says, now in his 3rd trimester of his civilian service career, David is happily out of his comfort zone, climbing a steep learning curve on the technical nuances of electric-powered aircraft vertical flight. He enthusiastically supports the emergence of the urban, on-demand air taxi market that maintains at least the current safety standards that we've all become accustomed to. So please welcome David Weber.
Thank you, Rick. So I'm basically going to kick this off for 4 of us, and we'll probably take a break here before we go to the other 3. But we got the FAA contingent here. I'm going to talk a little bit about Certification 101. And well, let me see here. Let's just go to that. I'm going to talk, basically give a Certification 101 brief for everybody. And this kind of grew out of my involvement with some of the new potential applicants into this market. It became rapidly apparent to me that I was going to need to explain what we do in the FAA. Quite often within the FAA, we have problems explaining that to ourselves at times. So this was good for me to do a refresher and go back to it. Being a flight test guy, I try to take all the big words and make them small, and try to go to the intent as opposed to the letter. So you'll see that in my Certification 101. After the break, Ife is going to talk about air transformation. There's been a lot of changes in the FAA recently, and he's going to go into some of those details. Dave Sizoo is going to follow that up with research and policy development. Dave and I work closely together in Kansas City. This is not research and development, it's research and policy development. It's basically using groups like NASA, and actually I want to learn from the Army's lessons learned as well. But basically feed all that work into our regulatory policy development, because I'm sure all of you will agree, if our policy is not written in a manner that's executable and usable, it makes life harder than it needs to be. And then finally, we'll end up with Gary Horan from the Engine and Propeller Standards Branch, and he's going to talk a bit about electric propulsion. So I'll go into mine. Basically, you can get this right from FAA.gov, and forgive me if some of you have worked with the FAA for a long time, but maybe some of you have not. Basically, we're in the business of regulating civil aviation, and it's all about safety. And that intent is no different from what I've already heard from the Army. You obviously, all of us have a mission to meet, so we can't have 100% safety. There's some risk involved, and it's all about risk management. And to get to those safety roles, we obviously have several areas we have to look at. So some of the main ones, some of the key FAA functions are the certification of the aircraft itself, and that's where the 4 of us all work in. We're basically in the business of delivering airworthiness and design approvals for products, for aviation products, aircraft. There's an arm that a lot of us deal with. If you fly, you definitely deal with them. It's flight standards, and that's the side of the business that basically is concerned with the airman qualifications and that type of thing. And those are 2 of the major parts in a group called AVS, Aviation Safety. Air traffic organization, every time that I run into somebody and I tell them I work for the FAA, they say, hey, I've got a buddy, do you know so-and-so? And every time I say we're a real big organization, and almost every time that buddy that they have works in air traffic control, and we're not any part of that. We're actually a pretty small part of the FAA. But as a new entrant, if you are, to the eVTOL world, you're basically dealing with 3 interrelated aspects, and that's basically the aircraft that you're designing, the airmen, and the airmen in this case, I'm personally not closely aligned with the unmanned world. I'm doing mostly manned eVTOL work right now. But in either case, the airman is the person who's responsible for operating that vehicle safely. So you're dealing with the airman somewhere along the way, and then of course you're operating in the airspace. And in a very simple sense, if you're designing a vehicle that's going to work and play well with the National Airspace System as it exists now, you don't need to worry about the ATO portion. You just have to worry about the airman and the aircraft part, and that'll keep you in the AVS organization only. So I want to expand a little bit on AVS. I mentioned Aircraft Certification Service and the Flight Standards Service, which are part of AVS. But I just want to read this word for word. FAA organization that's responsible for certification, production approval, and continued airworthiness of aircraft, and certification of pilots, mechanics, and others in the safety-related positions. So, you know, certification comes up quite a lot. And obviously, my job is Aircraft Certification Service. And every group you see here within AVS certifies in one way or another. We have some special groups. We have a group called AUS that's handling unmanned aircraft systems. Accident investigation. The idea there is to get the lessons out of the accidents and feed those into potential updates of regulations so that we can certify to the right standards. And you can imagine that evolves over time as technologies evolve. Aerospace medicine is looking at the qualifications of our medical quals, and you're being certified to a level of health depending on what your operation is. There's an air traffic safety oversight function, which is paying attention to what's happening on the ATO side to make sure that our certification rules are relevant. And of course, we're a big organization, if I didn't mention that already, so we have the last one there, which takes care of the admin function of a large organization. I skipped over one on purpose, but I left it bold to remind myself to go back to it. I want to point out that we are a regulatory agency, and as such, the rulemaking, everything that we put as a rule, we have to comply with those regulations somehow. We have to address them, and that's going to come up as I get into the Certification 101 part of this. If you are certifying an aircraft, you're going to have to abide by what is published, what is on the books, and it then becomes a question of how we do that. So let's talk just a little bit, what is certification? Well, certification is a little more than getting an airplane up into the air, getting an airplane up into the air safely. It's basically an acknowledgement that whatever FAA requirements you've been deemed to have met, you'll continue to meet those. And this is very similar to what Dave put up in terms of the airworthiness pillars. It's not just you've got continued airworthiness to deal with. You've got your safety assurance has to last for the life cycle of the aircraft. So FAA has different ways of doing certification. There are well-proven risk-based processes for each line of business. For example, if you build an amateur-built aircraft, you'll get an airworthiness certificate for that, and it's an experimental airworthiness certificate. But there are limitations put on that certificate, and those are meant to protect the public. And so if you follow those limitations, you're operating within the constraints of that particular certificate. When we type certify a Part 25 transport airplane, the level of safety for that is going to be higher because now we're talking about people buying a ticket and they have a certain amount of expectation of what they're getting. So, but basically in all cases, certification has to provide durability and basically whatever we're putting on your type certificate, it has to be durable over the long run, and we have to be able to go back and be able to enforce that if necessary. So recently you asked about why certify. Well, it's basically to manage the operational risk of flying, and certification provides safety assurance. And I'm going to come back to this term, safety assurance, a bit later in this presentation, but we want to have a certain confidence that that any product that is put out to the public is going to meet and continue to meet what the public expects of that product. I read a press release from I think it was last week or the week before, and I want to read this. Acting Administrator of the FAA, Dan Elwell, said that when it comes to the emerging eVTOL on-demand mobility market, he said, "What I'll tell you unequivocally, there will be no degradation in safety as we know it today." And he further stated that the public demands a level of safety in aviation that is unlike any other mode, and there's really zero tolerance to go back on what we've built with over 100 years of flying airplanes. So safety assurance, there's a combination of factors here. Airworthiness, the basic airworthiness, that's just how you, and what I mean here is that aircraft in a condition for safe flight. The design obviously matters. That's why we're in flight test and any other discipline. We're trying to shake out the design to make sure that it's going to meet the applicable requirements. We've got to make sure that the pilot or the operator is trained for the aircraft, and make sure that it's maintained in a condition for safe flight. Make sure that the limitations are adequate, appropriate, and are noticed. And of course, the airspace has to handle the vehicles that we want to fly in it. So here's some of our core responsibilities in aircraft certification. First of all, we've got to set the bar for a given product, and that bar is, we call it the certification basis, and that bar is going to be publicly noticed, which means the public's going to know where we're setting the bar for a given category class of aircraft. For the applicant, they need to determine how to clear the bar. How do they show that they are able to meet that certification basis? And typically, how that's done is the applicant gives us a project-specific certification plan, and hopefully we have some guidance for the applicant to figure out how to clear the bar. And what we'll do is we'll ultimately accept a means of compliance, and that means of compliance is going to be the standards and ways of showing that the applicant can clear the bar. And then what the FAA does is we find compliance, and that's the ensuring that the bar has in fact been cleared. And our notification of that is when we give a type certificate. So here's a picture of the good book, and the good book, like most good books, it's got a lot of line and verse that's subject to a lot of arguments. So what I try to do with the line and verse is break it down to the intent, and most of the time, if you can get to the intent, you can get a common understanding of the intent, it cuts down on the amount of arguments. And so I want to point out something here that's real important. Part 21 is that defines the certification procedures for products and parts. It is not a standard in and of itself. So any product you bring to us for certification goes through Part 21. So it's not a question of whether you're a Part 27 airplane or a Part 21 airplane. All airplanes, all aircraft are Part 21. What 21 does is it takes you to, there's several sets of standards that exist, and that's Part 23 through Part 35 are the ones we're used to. And I'll go into a little bit more detail on those. Sometimes, often actually, the regulatory rules that exist for each of those sets of standards for given categories and classes of aircraft, due to new and novel technology quite often, there's something that was not anticipated when the rule was written. And so what we do is we still have to address those rules. As I said earlier, we're a regulatory environment, so we have to address those parts. And one of the common ways to do that is to write a special condition. And that special condition is in and of itself rulemaking, and it becomes project specific and gets attached to one of those sets of standards. There's other things we can do, equivalent level of safety findings, exemptions. I won't go into details on those here, but I wanted to point out the special conditions because those are relevant to the rest of the discussion. Here's kind of a graphical. I'll spend just a little bit of time on this. So if you're bringing a new type design and you go into your Part 21 procedures, you're inevitably going to end up at 2117. And 2117 is the designation of the applicable regulations. Applicable is key. If I didn't mention it earlier, I should have, and I think I forgot to, but we cannot separate when we're figuring out applicable regulations. We cannot ignore the different operations. In much the same way that the Army was talking about their airworthiness procedures, we don't use in the civil sector, we don't talk about expectation of casualties. We don't use those words. But in a lot of ways, the same thought process is there. Where you fly your aircraft, whether people are buying a ticket to fly on that aircraft, those all play in to the designation of applicable regulations. So it's not one size fit all. We try to break things into category and class because that helps us with that thought process of concept of operations. And so some of the ones we have defined are the normal category airplanes, transport category airplanes, normal category rotorcraft, and transport category rotorcraft. We also have man-free balloons. That's interesting, but if you think about it, those are all for hire typically. So we have a couple other products. We have engines, Part 33, and propellers, Part 35. And so if you're going down the 2117A path, you are obliged to pick one of those categories. You can augment it with special conditions as required, as I mentioned earlier. The other path to go is to go to the 2117 Bravo path. And in this one, the idea of this is to give you flexibility to put together applicable regulations. But think of those regulations as standards. If you look at gliders, they reference to a advisory circular, and I put it in green there because it's not considered a rule, but it is the set of standards is referenced in that advisory circular, as is with the airship, does the same thing. And so since those standards are accepted by the FAA, you can simply put in a 2117B application, reference those standards, and augment them any way that you need to. It's similar to the tilt rotor that I saw a brief on today, the AW609. It uses a very similar path, but it creates a whole set of airworthiness criteria for the tilt rotor. You are obliged, when you're in 2117B, to look at all the regulations, because every rule that's in the sets of standards, there are 23, 25, 27, 29, 31, 33, 35, they've all likely been the result of a lesson learned somewhere. Quite often, there's blood involved, and so we don't throw those away. We look at those, dig into them. You can find the preamble to those rules if you're new to the industry. When you read those preambles, quite often you can find the reason for that rule and decide if it's applicable, if you think it's applicable to your new aircraft design. It's important to do that. In the 2117B process, you're obliged to do that, and you can use the rules as written. You can modify the rules. You can come up with your own specific requirements for your individual aircraft, so you basically end up with a unique airworthiness criteria, and that airworthiness criteria is subject to public scrutiny in the end. So as you can see, whether you go down the left side or the right side of 2117B, ultimately you get to the same goal, and that's a regulatory certification basis, something that has to be legally durable and enforceable. So what happens after that? So with the regulatory certification basis, what we do with that is you end up, when you get your type certificate, you have a type certificate data sheet. And this prescribes the conditions and limitations, like any other certification we do, under which that aircraft meets the airworthiness requirements that we've certified you to. And these are my words, but basically, to me, these airworthiness requirements, they tell the world what your aircraft is, as well as what its capabilities and limitations are. So it's an important document. And there's several areas. I've got them there in the slides. You can read it. I won't go through all those. But once again, if I can make one statement, though, that this type certificate data sheet does provide the legal framework for the continued operational safety of the aviation product. So for your aircraft, don't forget we live in a free country. We do allow, if you don't own every one of the airplanes that you build, people can modify that aircraft. And when they modify that aircraft, they're going to modify it to this standard. So this standard is important downstream. So I want to point out, we're talking about eVTOL. We're talking about on-demand mobility. We're obviously at a huge growing point, potential for a huge growth in whole new market segment in aviation. And I want to give you a thought that the regulatory certification basis can drive things like infrastructure. If you look at the regulations as they stand today on the books, I've picked a couple here, and this is just some performance regs. You can see in the transport, if you're a transport category airplane, you've got some, after any critical loss of thrust, you've got a certain climb gradient that you're required to maintain. That's a minimum safety standard for transport category airplanes. Likewise, for normal category, in this case I picked a multi-engine airplane, you've got a smaller, a lesser climb gradient, and that's, or you don't have any climb gradient at all if you have adequate crashworthiness. So you can see how this works when it comes to determining applicable requirements for any aircraft. We can trade off with different areas. If you've got crashworthiness, perhaps you don't need climb capability. If you don't have crashworthiness, you need a little more climb capability. There's trade-offs here, and it's all in the idea of coming up with equivalent level of safety. On the rotorcraft side, if you're a transport category A rotorcraft class, you've got a 100 foot per minute climb rate that you'll meet. I learned today that the AW609, I guess I understand that it has a minimum climb rate requirement of 200 foot per minute. I'd be interested to find out where that came about, but that becomes that's an example. True, yes? Yes, okay. And then if you're normal category rotorcraft, you may not have any minimum climb rate assurance depending on what you are. So if you're a new entrant to this world, what we look for, and this is not too different from the Army side, I think what do you call it, your AQS?
AQP and AQS, yes.
Yeah, and
qualification plan and specification.
And I was intrigued that you passed that to the OEM to come up with that, and that makes a lot of sense because they're basically suggesting, and I would offer that we, in essence, kind of do the same thing. We're a little bit off the map right now when it comes to the new on-demand mobility eVTOL. We don't have the standards. You can't go to a book of standards and figure out how to do on-demand mobility eVTOL. So we are looking to the manufacturers, and we're working with you to figure out what minimum standards are required to support the safety assurance for your product. What's going to make you socially acceptable and make this market segment take off. I do want to talk a little bit about performance-based regulations. So there's a shift, or there's a strategic plan within the FAA. It's not fully accepted through the FAA, but it certainly happened in Part 23 and is a big topic of discussion in other parts. And that's the shift towards performance-based regulations. So I just want to talk once again in a flight test manner, getting down to intent, of what this means. So in the past, for 70 years, 100 years, however you want to look at it, we have historically, taking our lessons learned, we've gone through a long and laborious rulemaking process, and our rules across all the sets of standards, all the sets of rules for the different product lines, has got the standards have been built into the rules. Over time, rules would get added, very few would get taken away, and so we ended up with a kind of a thicket of rules. And since they're rules, you have to address them, and it created a huge administrative burden. Part 23, recognizing this, went to performance-based regulations, and these are higher-level regulations, and for the most part, a lot of the prescriptive requirements, the standards that were built into the regulations, have been stripped out. There's still some in there, but they're mostly stripped out. And the idea of performance-based regulations is to have a higher-level regulatory rule supported by standards underneath it and means of compliance. So I kind of drawn this up. So when it comes to performance-based rules, I think of that as the top of the stool. And the stool's no good, it's got no utility without the standards and means of compliance supporting the stool. If you look at the AC 23.2010, and it talks about means of compliance and defines it, and I've got it written verbatim there. It's basically a detailed design standard that, if met, accomplishes the safety intent of the regulation. And I hope that makes it clear how we use performance-based rules. Once again, we only have performance-based rules in Part 23 at the moment. Maybe 10 years from now we will have more. But it takes a while to get through rulemaking. And here's a couple of means of compliance examples. And once again, the hope of the FAA, the strategic hope, is that industry moves faster than the government will move, faster than the Army moves. We know that. We know that that technology is always going to move faster. So we would love to shift the burden and the agility of coming up with those new standards to industry, because we know in the rulemaking process we're not quick enough to do that, and we don't want to stifle innovation. So what we want is FAA accepted industry standards. We want the consensus standards to be worked out, and the FAA will simply accept those, and we can then use those underneath our performance-based rules to give us the safety assurance that we require. But you don't have to wait for industry standards. If you are truly new and novel and there are no industry standards available, we have the flexibility to accept proprietary standards, project-specific proprietary standards. And as I showed you earlier, you can also go 2117B when do airworthiness criteria. And of course, we can always add special conditions. But I will stress that special conditions are rulemaking. So when it comes to urban eVTOL, on-demand mobility, Part 135 ops and low-altitude urban environment, this is all new to us. And we have little, I would argue, perhaps no policy that is directly that directly exists right now for small powered lift special class aircraft. And we have very few standards and means of compliance. Lots of stuff that can be adapted. There's lots of stuff that's being worked on, and all of that is free game for coming in and presenting to the FAA as being suitable to be an applicable requirement. And the good news is we have the regulatory options. But it's going to take some critical thinking on the parts of both us and potential applicants as to what the best path to take is. So we can add special conditions to address powered lift aspects of designs, perhaps, if we go under Part 23, or you can use 2117B and use airworthiness criteria that's developed specifically for your aircraft. But the end goal is the same. Basically, we have a thing called the risk continuum, and a big part, and I think this is a critical part, is to first approach the FAA and come to an agreement of where does your aircraft fall on this. There's a line there that's basically intended to show the societally accepted risk, and you can see up at the top you've got your Part 25 transport airplane, and at the very bottom you've got your radio-controlled airplane and small UAS. So somewhere in between that is where this new on-demand mobility eVTOL aircraft, and we have yet to come to a solid agreement on where that is. And I just want everybody to understand that we don't know where that goes. We need your help in figuring that out. And that's it for me.
Okay. Officially, we're in our break period at this time, so at HS request, we'd like to go ahead and give a break and get you comforted. If you have any questions from our first presenters, you might want to write it down now. If you want to, you can bring it here, and we'll be ready to answer those when we get to the question-answer period. But please write them down so you don't forget, because we'll take a break now. We'll be back in here exactly 4 o'clock for our last 3 presenters and then our question-answer period. Thank you. I knew if we took the break, we'd end up losing a lot of people, but to stay on schedule, I think we're going to go ahead and get started. And now that you've had FAA Certification 101, it's time to get down into the meat, okay? And we talked about the transformation, and that's about where we're headed to now, and all of the transition that's going on within the FAA. Hopefully we'll catch a lot of that in these next 3 presentations. Our next presenter is going to be Faye Ogunleye. I got close. Almost got it. Okay. He's the rotorcraft advanced flight control and system safety subject matter expert. He's been with the FAA now for 7 years and has worked in aircraft certification offices and rotorcraft standardization staff. Faye has a BS and an MS in aerospace engineering. His focus was on reconfigurable adaptive control systems, real-time telemetry modification and optimization, and control system health monitoring and fault detection and isolation. You can see this will come in handy on fly-by-wire. Prior to joining the FAA, he was in the Department of Defense for 8 years and worked at advanced fighter aircraft and systems development programs. He was involved in the test and evaluation of the fault detection and isolation system on the F-35 Joint Strike Fighter aircraft, as well as the integration system verification and validation and failure mode effects testing. In 2012, which is when I first met him because he came into my office, he joined the Rotorcraft Certification Office as the Advanced Flight Control Specialist on the AW609 tilt rotor and the Bell 525 helicopter. In 2015, he transferred to his current role, which is the Rotorcraft Standards Branch Policy and Regulation Office. In this role, he is the subject matter expert for policy and regulation pertaining to flight control systems and system safety. So please welcome Faye.
Thank you. So yeah, Rick and I worked together in the ACO, and it was great because I remember when I got hired and during the interview process, it said, hey, you know, the FAA, we're starting to get some fly-by-wire systems in here, and we're trying to recruit, you know, that specialty. So I said, great, you know, I'll make that transition from military to civil airspace. And literally the first 2 projects on my desk when I showed up was an air tractor and a Robinson R-44 rotorcraft. So I don't know if you know what those are, but one essentially is like a flying lawnmower, okay, and the other is it's an R-44. It's just what it is. And I remember Rick was like, "Oh, hey, you know, that's no problem. Why don't you come fly with me?" And I think it was a 407 at the time. And I said, "Rick, I don't know, man. I just got married. I don't think I should be flying, you know, single engine helicopters right now." But Rick was really instrumental in just exposing me to the miracle of rotorcraft dynamics and what's actually happening there. So it's great to be introduced by him. So today I'm going to talk about air transformation and also touch on a few system topics. So air transformation is basically the reorganization of aircraft certification office. So that's guaranteed to be the most exciting topic you're going to hear this week, or for sure. No, it's dealing with it's talking about us reorienting ourselves to accommodate the changing landscape in civil aviation, and so it's very pertinent to a lot of things that we're going to be talking about here today and this week. Okay. Okay, so why change? The aviation system is rapidly changing. It's placing greater demands on its participants. It's more complex, it's more interconnected, and it's more reliant on new technologies. The aircraft certification system in use today will not be able to sustain the level of success it's achieved to date. So technology advances such as those enabling advanced VTOL are coming in so quickly that the processes must be in place to be responsive to this rapid pace of technology advancement. So AIR needs to balance the business needs of its entities seeking certification, the applicants, with the public's expectation for safety. So each component of the aircraft certification system, which extends beyond AIR, beyond just the regulators, to include industry's responsibility to comply with regulations and the public's participation in the regulatory process, must all address the changes posed by this changing environment. So we have identified 4 major drivers to initiate this change, and the first is industry growth. So industry is expanding and contracting at a much faster pace than the FAA can currently match. We're seeing a very diverse set of applicants compared to what has historically been the case. And the types of conversations and processes we need to have in place so that we can administer the services that are needed, regardless who walks in the door, are going to be different. Next, the globalization of aviation. Industry is made up of international networks and complex business arrangements that are challenging AIR traditional regulatory models. Additionally, we have a heightened expectations. The flying public, industry, and government entities continue to increase their expectations for AIR to be agile and efficient in certification processes. Also, the last one is the velocity of change. We're seeing just a rapid change in the industry that we have to be remain agile to adapt to those changes. So the air transformation is a comprehensive, multi-layered, long-term endeavor. It starts off with the blueprint, which contains 8 vision elements, which is the first block that you see there. Then building off the high-level vision and plan presented in the blueprint, the comprehensive strategic plan, the CSP, will outline detailed requirements for internal and external stakeholders. It is the what we need to achieve and will provide a tactical framework for achieving the transformation vision. The CSPs have been drafted by teams composed with the appropriate stakeholders for each of the 8 vision elements. And lastly, the integrated implementation plan will provide the details on how to achieve the specific requirements detailed in the CSP. So Air Transformation Blueprint identifies 8 vision elements that are considered essential to realizing air transformation. First is accountability framework. This helps clarify FAA and industry's role that form the backbone of the airworthiness system. Under this framework, final accountability for compliance to the safety regulations rests with the organizations that seek or hold the certification approvals. Risk-based decision-making will allow AIR to scale the level of rigor used in approvals and oversight and leverage resources more effectively. To promote international partnerships, AIR will employ a methodical process to establish, build, and maintain confidence in foreign aviation authorities. Next is fostering innovation, which I'm going to discuss more in the next slide, but this will minimize barriers to the safe and timely adoption of innovative products, technologies, and practices. Strengthening AIR's industry relationships will promote a collaborative relationship between AIR and industry, and the basis of this relationship will be more accountability, a mutual respect for each other's value, and a shared commitment to safety. And next is a collaborative work environment. AIR will realign our organizational structure to minimize geographic restrictions on resources. And additionally, AIR will implement a learning organization and employ a information management strategy. So the goal behind Foster Innovation Vision Element is to encourage the use of innovative products and design, and that we at Aircraft Certification have a culture that embraces the use of new technologies to promote safety in aviation, and that we are able to create a path to move these technologies from conceptual design to a certified product in a safe and timely manner. The transformed system will minimize barriers to the safe and timely adoption of innovative products, technologies, and practices. So to do this, AIR will engage industry early to understand new ideas and to ensure that there's a path to compliance for the design, production, and operational use. Where innovation pushes beyond the current means for achieving compliance, AIR will proactively engage in establishing standards in collaboration with industry organizations and international bodies. And you will hear from Dave Sizoo, who will present the research arm of this specific effort. And then for organizations that are new to aerospace, AIR will help them navigate effectively by introducing them to the regulations and policies surrounding product design and manufacturing. And these measures will pave the way for innovation that will enhance safety and the value of aviation. So our office, we've been able to see this come to fruition over the last year. Recently, we were approached by an applicant desiring to design a Part 29 autonomous rotorcraft. And so we got our management team together along with an executive manager from Flight Standards, and we went to the applicant's facility and got a demo of the product and saw it flying and got a high-level brief of their design in order to provide us with a better understanding of the applicant's intent and how our respective offices could provide the services that were needed. So then this was followed on by what you could call a pre-application fan meeting, where the applicant's design team came down to our office and met with FAA specialists from the Rotorcraft Directorate, the ACO, the MITO, which is in charge of certification, AEG, AFS, and we spent the entire day just going through the new and novel aspects of their design in a very collaborative and two-way conversation. And so that helped us, and one of the outcomes of that meeting was for our office, to start to engage with the applicant to identify regulatory gaps and start to formulate a path forward. Now, all this took place well before an application. In fact, this was about 2 years ago, and we're still waiting on that application. But even without an application, the time spent with doing that effort has been extremely beneficial. It exposed the FAA, our office, to new technologies being utilized in the aerospace industry. And it helped us start to look at our regulations and means of compliances to identify potential pitfalls or shortcomings within them. It also helped facilitate conversations within the FAA amongst our different offices around these new technologies and operations. So all these things help aircraft certification be in a better position to certify new technologies. So this is the essence of the Foster Innovation Vision Element that's taking place as part of air transformation. So I'm going to do a hard shift and talk about machine learning and fly-by-wire aircraft, or fly-by-wire systems. Oh, go the right way. Yeah, so there have been lots of conversations around neural network. The aerospace industry shares many of the same challenges as the automotive industry when it comes to the use of machine learning methods. So we've had multiple companies share their desire to utilize machine learning to implement several aircraft functions. So today we don't have any regulations or guidance for machine learning algorithms or an industry standard. They're new or novel, and they typically are non-deterministic, and so therefore they don't provide repeatable responses to a same input. In a paper entitled "An Analysis of ISO 26262, using machine learning and automotive software," the author states, a machine learning model typically does not operate perfectly and exhibits some error rate. Thus, correctness of the machine learning component, even with respect to test data, is seldom achieved, and it must be assumed that it will fail periodically. So this should drive every system safety engineer absolutely crazy, because we live in the V, you do validation, verification, and you're done. But this highlights a big challenge when using artificial neural nets, and they need to have an architecture that can mitigate any errors. It can be very difficult to demonstrate that the system using an artificial neural net can perform their intended function under all foreseeable operating conditions. So this means the training data would have to cover all possible conditions to include expected weather, operating conditions, emergency conditions, and sensory imperfections. Since machine learning is new and novel and we don't have a means of compliance, we need to gain trust in this technology. We need to crawl before we walk and walk before we run. As is common in the automotive system, a phased deployment approach seems reasonable. So a phased deployment to the V process can be done by identifying well-specified operational concepts to limit the scope of operation and safety risk, therefore the necessary scope of requirements. This could include limitations in environment and operational constraints that limit the autonomous operation. So the automotive industry is also using an enhanced data recording to allow the reconstructions of the circumstances that resulted in an anomalous behavior of the artificial neural net. And then this data can be analyzed to determine where the deficiencies are within the verification process and the training data. AVSI is a research consortium managed by Texas A&M, and it's comprised of major aerospace companies and government organizations working together with academia to solve problems common to its members. So a new machine learning research project was just started, and the primary focus is artificial neural nets. The research team consists of members from industry and the FAA, and the 18-month project has 3 specific tasks. The first task will investigate verification methods for machine learning that could be applied to safety-critical aircraft functions. The second task will define the process flow for allowing machine learning into aerospace systems with special considerations for the certification aspects in this process. And the third task will investigate methods for bounding the behavior of a machine learning algorithm used in an embedded system so that the overall system stays within safety bounds. So since we've had several applicants inquire about machine learning to automate pilot functions, we have drafted an artificial net issue paper, and we're planning on turning the contents of this issue paper into a white paper so that it can be made available to public for industry comment and authorities, and we can get that feedback. So I'm going to talk, this is my last slide, I'm going to talk to fly-by-wire. So the ASTM F44 have created a specific working group to develop performance standards for fly-by-wire Part 23 airplanes. So I believe this working group is fairly new, it's still on a ground roots effort. So if you feel that you can participate or have something contribute to that, I would encourage you to attempt to participate and join that working group. And I believe there's some folks here from ASTM this week that you can reach out to for that. To date, for today, the current method for certification for fly-by-wire systems has been accomplished through the use of special conditions and means of compliance issue papers. So these issue papers have been around for several years. They get propagated from one aircraft to the next with some slight refinement along the way. And I've had the opportunity to spend a lot of time reviewing these issue papers to determine the applicability for the 525 and 609 aircraft. And what we found is that though the technologies are generally similar to their Part 25 counterpart, there are unique considerations to account for when you transition this technology along with its processes from a Part 25 environment to rotorcraft or powered lift. The design constraints, the targets, and the operations are significantly different, which results in different types of system architectures that end up getting implemented. Additionally, there's substantial variation between the types of failure modes and aircraft effects between a Part 25, 29, and powered lift aircraft. And so these are just a few aspects that influence what type of policy would be appropriate for a fly-by-wire system. And then the transition to an eVTOL aircraft with urban mobility operations will introduce even more unique considerations than we've seen in the past for fly-by-wire systems. So 2 years ago, our office published a fly-by-wire handbook for rotorcraft. And that policy really started about 20 years ago. And yeah, sometimes it takes that long. So it started 20 years ago after the V-22 and before the 609. And it was a collaborative effort. It was really led by industry, by the designers of the architectures from Boeing, Bell, and folks that worked on the V-22 and the 609 and other fly-by-wire Part 25 aircrafts. And so in 2012, we created an ad hoc working group with TCCA and EASA to update the contents in order for publication. But due to time constraints and the lack of a formal working group, we had to stop the collaborative effort, and the FAA went ahead and published the fly-by-wire handbook. Last year, the CMT, which is the Certification Management Team, and this is an international governing body across all products types made up of directors from the major certification authorities. They chartered an international working group to update this policy, and the objective is to update the policy accounting for lessons learned from past systems, and to ensure it's applicable to today's environment, and to ensure that it's harmonized between EASA, TCCA, ANAC, and the FAA, which are the folks that make up the body that makes up the CMT. And so I'm leading this effort, and I'm very optimistically targeting the end of the year to complete this work, but I've been told that any harmonization effort is like a home remodel, and you can double the time and the cost and add 10%, and that's about how long it's going to take you to do it. So we'll see how long that takes, but hopefully that will be made available here pretty soon. And that's the last slide.
I'll let a face set the computer up here, and I'll introduce our next speaker. Our next speaker is going to be Dave Sizoo, and has already alluded to Dave. Dave is a test pilot with 32 years of professional aviation experience. He holds a Master of Science in Aeronautical Engineering from MIT. He served 20 years in the U.S. Air Force and is a graduate of the Air Force Test Pilot School. I won't hold that against Dave. As an F-35, another F-35 guy, okay, is a Joint Strike Fighter test pilot. He was heavily involved in the testing of flight controls, handling qualities, and pilot vehicle interface. This work included tuning unified, in quotes, VTOL flight control laws to allow for seamless blending between VTOL and forward flight. And if you've flown the sim out here, you probably have seen what that means. They do have the F-35 simulator out there with some of that blended control. Following Dave's military career, he continued flying as an experimental test pilot at Gulfstream before joining the FAA as a flight test pilot at the Small Aircraft Standards staff in Kansas City. He leads the staff's research projects in flight controls, mechanical systems, and human factors. In 2017, he was the recipient of the U.S. Department of Transportation Team Award for leadership in general aviation modernization efforts. Dave has logged time in over 150 aircraft, is type-rated in over 10 jets, and is qualified and current in helicopters and gliders, and that's a lot, okay? I did say current, by the way. Right. He is an avid general aviation pilot, instructor, and evaluator. He is passionate about bringing advanced technologies to small aircraft to make them safer, easier, and more affordable to fly. Please welcome Dave.
Thank you, Rick. And thank you to Mike Hirschberg and the rest of the VFS staff for hosting us today. Thank you all for coming. Let's see, clicker. So normally when we talk about research, we always talk about research and development. And typically the development is development of a product. But today I'm going to take a little twist and talk about research, not developing a flying product, but research to develop policy for the FAA and for applicants that will try to certify a vehicle. So this next slide is talking about the type certification process. That TC is sometimes referred to as type certification, and this is a notional level of involvement for the different divisions within the FAA during the course of a normal project, from concept all the way through requirements definition, and then the granting of the TC is what the big celebratory date when an applicant applies and they get their type certificate. And then after that is the post-certification activities. And as has been pointed out earlier, the FAA reorganized recently, and we have a couple of divisions that are important for applicants who are trying to certify a product. The blue triangle is the Policy and Innovation Division, and the green triangle is the Compliance and Airworthiness Division. What I inserted in Flight Test Orange is the Research for Policy Development triangle. And the takeaway from this chart is that this line here is the TC application. That's when an applicant formally applies to the FAA. But what I want you to take away is the fact that the FAA would like to interface with applicants well before you apply for a type certificate. In fact, we would like to partner with NASA and industry and the military to do research for policy development. So that's what this slide talks to. Why do this type of research? Well, as regulators, we can keep up with the rapid evolution of technology and industry. It gives us insight into the gaps that exist with current regulatory standards and, as Dave Weber talked about, the means of compliance and the methods of compliance. Two key areas that applicants have to show compliance to get a product certified. So many of the advanced VTOL designs actually blend propulsion with the flight controls. So Rick was very astute to get propulsion and flight control experts on this panel. When we certify a vehicle that has blended propulsion and flight controls, we have to look at it as an integrated system. So one of the things that we have organized within the FAA is a team called the Research and Policy Integration Team. And that team works with the standard staffs from the old directorates. There were 4 directorates. You had Transport Directorate, you had the Small Airplane Directorate, you had the Rotorcraft Directorate, and the Engine Propeller Directorate. So this team, Research and Policy Integration Team, coordinates among all those old directorates. They're now part of the standard staffs. And that's the team logo, Research and Policy Integration. The idea is to foster communication, identify regulatory gaps and method of compliance and means of compliance gaps, then to perform research to actually fill those gaps and get empirical data that we can use to figure out the means of compliance, the method of compliance actually before an applicant applies. So key to this whole construct is working with industry. And when industry develops an advanced or a prototype, an advanced concept demonstrator prototype, we can really gain a lot of insight into the new and novel designs. This last bullet here is the plea that we would like to engage with you, the applicants and industry, early in your prototype development so that we can build this relationship together. This is a pretty busy slide, but basically it's a notional process that shows how research could feed an MOC or a means of compliance. As an example, I picked some new and novel technologies circled in the upper left. You have fly-by-wire, you have runtime assurance, you have adaptive controllers that Ife kind of mentioned, and you have real-time parameter identification. These are just some new and novel areas that we really don't have specific means of compliance. We have developed special conditions to certify transport aircraft and to certify rotorcraft. The Bell 525 and the 609 are some examples. But this is a notional process that shows how, by partnering with industry, we can actually perform research and start to develop draft white papers and develop policy that can feed an ASTM or an industry standard. ASTM is not the only industry standards we will use. We will use industry standards from RTCA or SAE, for example. And you don't have to go down this path with research. Industry can engage with those standards bodies to develop their own means of compliance. But this just shows an example of the Policy and Innovation Division on the left, and then using those means of compliance at the Compliance and Airworthiness Division. Think of that as ACOs, Aircraft Certification Offices, that actually do the testing and the finding of compliance. 3 or 4 members in the room were present here back 2 years ago. It's hard to believe that it was 2 years ago we held a summit to try to get ahead of some of these evolving technologies. So Ed and Carl and folks from Joby were out at that summit, and it was a great gathering of individuals. The goal of the summit was to focus the research activities that we've been involved with for the last 2 years. And as a result of this summit, we have initiated several different research projects. I just highlighted a couple in the green on the left. And the gray box on the right shows the participants by the numbers, I say, from the Fly-by-Wire Summit. And I was really pleased that we had several airframe manufacturers present, because that is where we learn from industry what is important to them. This next chart, again, shows sort of a capabilities roadmap that we are using to try to focus the research. And in the upper right, you'll notice that I've called out NASA and AFRL, Air Force Research Lab, but we really want to grow some partnerships with the Army and some other military entities as well. On the 3 lines, you'll see that we have general aviation on the top, we have UAS in the middle, and we have sort of this eVTOL line on the bottom. And they're all capabilities that have common elements. And the research that we do for general aviation technology feed the research for UAS technology, and then that in turn feeds the eVTOL manned aircraft. So I took a stab at guessing where we are on the spectrum. And you can see on the general aviation spectrum, I think we're pretty far along, because we have certified fly-by-wire in several different products, both rotorcraft and transports. On the UAS side, we're sort of evolving. And on the eVTOL side, we're getting started. But the research actually, I think we are ahead of the game with the research, because we are using that research to feed the policy development. So this next chart is an eye chart with a lot of acronyms. The takeaway is the focus of a lot of the research is the center hexagon, which is augmented flight path control. That is kind of central to what we're studying. And the arrows are research projects that we've initiated and have been ongoing now for about 4 or 5 years, actually. We have many other projects just coming on contract. And the blue hexagons surrounding the augmented flight path control are kind of functions that will support eVTOL safety and on-demand mobility in the going forward with new vehicles. So one of the areas that we are engaged with, industry and NASA, is on assured autonomy. And to me, these are kind of the three key points for the architecture of assured autonomy and some of the items that will be of key interest in the certification of autonomous vehicles. So in summary, we're proactively engaged in research, and we solicit involvement with applicants, industry, academia, the military. We're open kimono. We'd like to work with you to develop policy together. And those last four icons there tie back to Ife's chart that talks about the 8 vision elements for how the FAA reorganized. So with that, I'll turn it back over to Rick.
While he's doing that, I'll go ahead and do an intro here. This is our last speaker for this panel, and it's Gary Horan. And Gary is from the Engine and Propeller Standards branch, Electric Propulsion Focus, and he's the subject matter expert. He has been with the FAA for 18 years as the FADEC, and most of you know engines, then that's the Full Authority Digital Engine Controls, subject matter expert and rule owner. He is also the FAA subject matter expert for atmospheric radiation. Gary has a BS degree in electrical engineering and an executive MBA. Prior to joining the FAA, he was with the industry for 31 years and worked on the design, development, and certification of FADEC from its very infancy. In 2015, he began the transition for electric propulsion and hadn't had a time to get his head up ever since. So please welcome Gary.
I want to share a few things. I picked up a little pieces that I've heard today that were not obvious to me going in, and so I thought I should touch on them. One is that never be the last speaker following somebody with such incredible credentials. The other is that we've talked in a number of cases, you've heard it repetitively, that it takes us a long time to get rules done and issued and whatnot. And I want to give you a great example. And probably there's going to be some of you who this is going to be familiar to. Well, we use special conditions, as you've heard, and they are a process that is a rule-making process, okay? But we use them for very specific things. Sometimes we tend to abuse them. I'll admit that, and this case in point is one, and it's interesting, the abuse. It was for HRF and lightning. Now, HRF and lightning has been something we've dealt with in this industry for a very long time. And for 25 years, the only rules relative to it were special conditions. So it took 25 years before they converted a special condition into an actual rule. So don't get your hopes up too high for all the stuff I'm about to tell you here about the making of rules for electric propulsion, because God knows how long that'll take. And it has taken me. It's interesting that comment that Effie made, which is about like a home renovation project and it taking twice as long and costing twice as much. That's exactly what I'm seeing with what I've been working on. So I'll share that with you, and because I get questions like, well, how soon? When will it be available? And I keep saying, I wanted it last July. I'm hoping that by the end of June we're going to have it. So anyways, so let's get on with this. Yes? No? Well, and I'm the guy that's here to tell you that, my background is in electronics. Right now you have got lots of faith. Okay, so one of the common questions that has come up, both internally and externally, is the e-motor, does it fit into the current regulatory operating modes and whatnot? And the answer is multiple. One is that you have stated it as a slightly different question, is do the technologies fit into the current framework? And the answer is yes, absolutely. But on the other hand, we also have to use, to accomplish that, we have to use these special conditions or exemptions or equivalent levels of safety. So that's but we have the tools, so fear not, we're going to be okay. The other question is then are the new technologies covered by the current rules? The answer is, well, a little bit. It takes some real interpretation to get you there, and that's what's been happening up until what's coming, okay, which is what I'm going to tell you about. And so one of the aspects of it is that we recognize and we have to adapt. We have to adopt new and modified rules in order to better match what is the world of e-motors. Okay, so it still doesn't. I mean, okay, so yeah, I got it there. So the other question that popped is what I really want to talk to you about is where are we right now? Where do we stand on this evolution of, or possibly revolution, of going into e-motors as opposed to our tried and true turbines and recips, okay? And then what's next? That's the other aspect. What's next in this world of electric propulsion? So one of the things that, that I want to stress here is that we're not going alone on this. There's an inordinate number of committees, organizations such as this, that are working towards this world of the electric propulsion. So and what I'm trying to list here is, and truthfully, these are all committees that I am either part of or at least I'm watching as they evolve and what do they do. So the one that you've heard most about today is probably the one that has been the most help so far, and that is the ASTM committees. And it's a mix of the F-44 and the F-39, and it's F-39.05. Why, I don't know. But that organization has helped me a lot get through what I've had to get through. And the initial one that I've been working on with so much of my time is the one for the, I can't read it from here, WK, can I do this? No, it won't. This is inert. Let me just try something here to help me. No, that doesn't work either. We got to go back. Wouldn't you know it? It'd fall apart for me. Okay, now I can't get back. Oh, at the projector? No, I can't even step back. I've never seen.
I think it's because there's like 10 presentations open.
Oh, maybe close some.
Yeah.
You should only hit 3.
Oh, wow.
It's got like a million of them open.
Close those.
So it's probably like flipping slides on some presentation.
It's changing some other set of slides. Yeah. That's very helpful.
Yours is this one, right?
That's mine, yes.
Okay, I won't close that one.
That one
But I will close the other 10.
Oop, that's mine.
Oh,
Oh, maybe it's good to close it. Just reopen it.
cancel. Yeah, it has. Oh, it's crashed.
Yeah, it's crashed. Can't even.
We made it to the last presentation.
Yeah.
Right?
There. Now it's working.
Oh.
You just went back. One more. One more. Okay.
We're up and running?
Fantastic. Fantastic. Except for I still can't see it here, but that's all right. So yeah, I know, but that's fine print. I did that on purpose, but it's not helping me now. So that committee, and it's the working group is coming up with a document, WK 47374, which is the EPU standard, and that is the foundation for what where we're starting for an electric motor. And the next slide, the next couple slides from now, it'll be a lot clearer as to why that's evolving. But there's another committee under the F-39, and that's the one that's developing the propulsion energy storage system. And so there's that activity that's going on, and then there's still yet another, and let's not even worry about it. That's F-44, and that's the integration of an EPU into an aircraft, okay? So again, that's all about Part 23, but I can assure you that the EPU is not about Part 23, okay? It's a kernel for an EPU, electric propulsion unit, for anything, okay? Anything in aerospace, okay? And that's my goal, okay? The next committee or group of committees is Gamma. There's two under that are of very important interest to the electric propulsion. One is the EPIC, which is the Electric Propulsion and Innovation Committee. And then there's the ELC, where I keep teasing Greg Bowles about it, because I asked him, what's the ELC stand for? And he says, oh, I don't remember. But it's the committee that's working on any of the writings and standards for that they would be involved in for electric propulsion. But, so they have this acronym that they don't have the history on it, and they don't remember what it is. The other, of course, is SAE, was mentioned earlier. And SAE has got a number of activities going on in this realm. One is the E39, which is UAS propulsion, and that's an interesting one. I'm not sure if that one's going to survive, in all truth. The reason I say that is because they just aren't getting enough traction yet. It may just take a while. But one of the real quandaries in that, from my perspective, is exactly what I just hinted at a minute ago, which is what's the difference between UAS propulsion and manned propulsion? I don't see it. We don't do something different with the propulsion unit because of the type of aircraft it's on necessarily, okay? So I'm not sure that I see why that one exists in the framework it does. But the other one that is having some influence and guidance in all of this is the EASG, which is the Electric Aircraft Steering Group. They're a steering group as opposed to a technical committee. And what they're doing is they are trying to provide the guidance on how do we get to and who develops what standards for SAE in the realm of electric aircraft. Okay? So they're one of the guidance people. And out of that is also come just recently, very recently, the idea of forming another new subcommittee, which I've dubbed, because they haven't, E ? And it's probably really supposed to be question mark. Well, maybe it's only 2 question marks. But what it is hybrid electric propulsion units for particularly aimed at Part 25 transport. Okay? Now, I look at that again, and I question the why. Why for 25? Hybrid propulsion should not necessarily be specific to size of the machine. It may turn out that way, but I don't know why start down that path. But what it's doing is it's getting involved the other end of that spectrum. Remember the safety continuum that you were shown? This is trying to get the guys that are on the top end of the curve, the transport people on board, up to speed, starting to go down the path to determine what are the requirements for, what are the specifications for propulsion units for that size aircraft. And without any doubt in my mind, that is going to be a very helpful group, because they will be getting that dimension, that end of the spectrum, getting that up to speed on what's going on down at the end that we've been working at so feverishly recently, okay, with all these other companies. So that's brand new, okay, and I want to tell you that wasn't, I used somewhat these slides about well, let's see, 1st of May, 2nd of May, and on the 2nd of May, that was so new it hadn't made the charts. So we're talking about really near term what's going on, and I'm going to tell you about something else on this next slide that is, again, even further along, that has just popped up this morning, to put it in perspective. So what else is the FAA involved in? Well, we're involved in this Propulsion and Power Systems Alliance, PPSA. That is an interesting committee. It is formed of just U.S. government agencies. It involves NASA, and NASA is the organizer for it. DOE, DOD, and I believe, yeah, DOE, DOD, and FAA, but that's really DOT. So there you go. We've got all the government together figuring out something. Well, I'll give you a hint as to what they're trying to figure out. They're trying to figure out where there's redundancy, where is there things that are going on that could help each other, and where are the links, and who's connected to whom, and on what research project, or on what, you know, what planning and what development. And so that one is very interesting. That's the one where I just got notice this morning that NATO is in the process of putting together a what they're going to try to do is they're going to try to leverage the hybrid electric air vehicle technology, and they're going to be hosting a research symposium in about a year from now, I guess, and there's a call for papers out. So once again, it's constantly expanding the people that are looking at electric propulsion and what to do about it. So hopefully it's all going to help and not going to hinder. You know, it may tire us out, but you know, so be it. Then there's so that covers that aspect. Then there's also the fact that within my systems branch, we're reaching out to many other organizations, including directly to DOT and DOE and NASA and DOD. So we're also trying to reach out and touch all the people that are involved in all of this stuff. Now, I looked at it from the perspective, this is months and months ago, I looked at it perspective, said, okay, electric propulsion, electric motors for motion. And I said, let's see, who uses that? Well, automobiles use it, trucks use it, buses use it, trains use it, boats use it. That makes up all but one of DOT. So we're the outsider, FAA, just coming on board, just starting to go to electric propulsion. The other guy's been doing it for many years in some cases, and in at least a reasonable number of years. So why can't I reach out into DOT and find the people that have already been working on this and already doing this, and they can give me some pointers and some hints? I want to tell you that was a real challenge, trying to reach out and find those people, partially because those organizations don't have regulations per se. They don't have the rules. They use industry standards. Well, voila, that's what we should be doing, right? So we're doing that now. I have finally found the people, and I found them on the day that the government, remember the government was shut down for one day? That day, we were shut down. FAA was, we weren't supposed to work. So needless to say, I'm an idiot, and I was on the computer, and all of a sudden I started getting emails, and I got a chain of about 5, 6 different emails. We were all from these people at DOT and DOE that had been involved and are involved and are interested in what are we doing and what's, you know, they want to know what we're doing. And I said, that's fascinating. You shut the government down and all the people, all the technical people start talking to each other. It's kind of interesting. What a wonderful dimension we live in. So I made a comment like that on the chain of emails, and somebody said, well, most of us are with the National Highway Transportation Safety Agency. And guess what? They were part of the critical infrastructure that had to work, even though the government was shut down. And I thought about that for a minute, and I said, and the FAA wasn't? Interesting point of view on critical infrastructure. Anyways, so the other thing that we've got going on is we're coordinating within, as you've seen, as you've heard. And by the way, one question that has recurringly come up is this reorganization of the FAA. And why did we do it? And what sense does it make? And is there any benefit to it? I'm going to tell you right here and now, I was one of the people questioning that, okay? But right now, I absolutely believe it has had a positive impact. It has had a very beneficial impact of having these standards branches working up and down our silo, but much better than we used to. Because we used to not be in those silos, we were in the Directorate silos, which were more horizontal, I guess, so they were silos laying down. But it's actually working, it's actually helping. So, you know, we can't write it off. So, and lest we forget, the other aspect that we have is we have these ongoing projects, pre-certification, you heard that term just a few minutes ago, pre-engagements, okay, with the FAA and the applicants or pre-applicants. And we're working together to work on Dave's orange triangle. We're trying very hard to make that all work. And we've got an innovation process that we're putting together, AKA innovation centers. I'm not supposed to really say that, but I didn't say it. So it's an ongoing effort to get us up the step, ready for certification of this very fast advancing process. So ASTM standards versus rules, okay? Because what I've been working on and what I'm spending most of my energies on is these standards, the ASTM standards. Now, the engine and propeller group did not have the benefit of that 10 years of development of the performance-based requirements that Part 23 had. And so when I stepped into this world, I had to figure out, okay, how am I going to get there? How am I going to use ASTM to give me what I need? I didn't want to just try to create the means of compliance through ASTM that satisfied the Part 33 rules as they were written, because the Part 33 rules are written as very detailed and very specific about what you need to do. So the question was, how do I get there? So what we did is we decided we needed to have this kernel of a idea for the electric propulsion for the EPU, and we started tearing apart 33 and saying, what do we need? What do we need to keep? And what we ended up with is this first version of this standard, which is going to be something that isn't our end goal. We're starting out where what it's being called now is pseudo rules, because it's got rules plus means of compliance in it. So it's kind of like a mini 33. But that's not the end goal. And the end goal is to, and this is the first step right now that we're in the midst of, trying to get to the end here. We're getting damn close. I would like to see us ready for publication by the end of June. I don't know if we're going to make it. It's going to be close, though. And what it does is it takes the 33 rules and it looks through them, comes up with, proposes this working document, and then it gets published. Okay, now again, that's not the real format of the typical ASTM standard because it has the rule type words in it. So the next step, and I've already begun going down this path, is to strip out of that standard the material that will be the performance-based rules for an EPU. And we will put those into a special condition. And again, that's a tool we can use, so we will use it. And what we will have left over after we strip out that is we'll have the performance, we'll have the means of compliance for satisfying those performance-based rules. Rules, requirements, I don't care which, you know, it's an R. And then we'll take that document and get that published as a true ASTM standard. So that's what we're trying to get to. The next steps, and these are notional next steps, but we're already working on the top one. We are in the process of launching a new task group to develop what needs to be added to an EPU, because remember, an EPU in these terms is just a motor. It's got a shaft, a turning shaft. That turning shaft is not going to create much motion in an aircraft unless you put it on the wheels, and then as soon as you take off, it's not doing much. But we got to have a thruster. It's either a fan or a propeller, whatever it's going to be. And so we're going to start up the group to come up with a true set of requirements for thrusters for EPUs. The other one down there is the hybrid electric, and that's one of the next steps too. And it probably won't actually happen because the other activity through SAE will probably take over and pick up the hybrid electric, but only time will tell. It's hard to imagine what it could be. So standards development is many things. I used to say it's actually frightening, and my management said you don't want to tell people that it's frightening, but it is. And it's mostly frightening because of the speed at which this is all moving and coming at us. The advances are very interesting and very challenging, even for somebody who has a EE background like myself. It's challenging to deal with these new motors and whatnot. So we're learning about this old technology, right? This is not new technology. Motors have been around for how long, you know? So, but there is some aspects of these motors that are, you know, these high density and high performance units that are very new to us. But it's also new to aviation. And initially, and this, I'm starting to get over this one, but initially it's very difficult to fully understand the failure modes of these electric motors. Now, our regulations are heavily based on failure modes. As somebody said earlier, that, you know, something happened, something went wrong, and so you wrote a rule, said, don't ever let that happen again. So that's where we're at. We need to better understand the modes of failure for these electric motors. Now, I'm not, you know, the obvious failure modes are a little too easy. You know what's the, you could come up with top 4, any of us could come up with the top 4 for electric motors. But it's the details of why and how and what could you do about it. So I'm working with a number of companies now trying to come up with what do we need to really concern ourselves with. So we are engaged with industry on this learning process. So they're learning what we are, we're learning what they are. And so it's a mutual society. One question that has recurringly been brought up, and that is, are e-motors safer than combustion engines? You can see why you'd ask that, because the question is why all this energy going down this way? Well, we know one reason, it's greener. We know another reason, it's quieter, okay, in large part. However, the answers to that question are multifold. One is that both engine types, whether they be e-motors or combustion engines, have the same hazards at the aircraft level. So you don't see any real benefit there. The design of an E-motor is very simple by comparison to, if you think about a reciprocating engine, a radial engine of all things. I mean, those are monsters of complication. Turbines, with all the details of what goes on in the world of a turbine. So the bottom line is that they are simple, and integration of these allows us to take advantage and improve the safety. The use of the distributed propulsion, and then the how you control them and how you control, you don't necessarily control each engine all by itself. They are interrelated when you get into a distributed propulsion system. The integration, though, is something that has to be looked at very closely. Another aspect, E-motors have proven on-ground experience. I explained that a few minutes ago when I said everybody's been using these motors for a lot of things on the ground. So we're gonna learn from that. However, the combustion engines have a lot of experience from in-flight. So it's a trick to take the two experience spaces and meld them together to get what we need to know about these to make the electro propulsion machines so much more reliable than their predecessors. And I believe we're going to get there. The current rules are also, and this is one of the problems, are based on 50 years of continued airworthiness experience. And it's hard to just set that aside and say, okay, we're going to start up with electric motors, and it'll be okay, don't worry about it. So what do we have to do about that? Well, number one, we conclude that E-motors look very promising in terms of that reliability. And E-motors are a young technology for aviation, and those are kind of pros and cons wrapped up in with the same bow. And I believe that's it.
Well, with a little of our technical difficulty, we've kind of run over our time, but I see there's still some interest here, so I think if our panel will indulge, we will take a few questions before we complete. Dr. Sragi. Would you please wait to the microphone, because this is being recorded, so we'd like to keep it for record.
There's a lot of dependence on what has happened with Port 23, but 27 and 29 are also being updated. Is that correct? The way I understand it is they're moving towards a performance-oriented...
I think AFA has that answer there.
I know that they got an NPRM that's out that says 79, but 27. Trying to do the same thing with those as was done with 23, it sounds like.
I believe it's at the beginning, right?
Yeah, that's a good question. Thanks for that. Yeah, so there is an industry group that is working on that and trying to determine if they're going to go to a performance-based rule set like Part 23 has done. Then what I am hearing is that initially is that they're not thinking a wholesale rewrite like Part 23, but maybe picking out specific ways to go performance-based. But beyond that, I'm not involved in that committee, but that group is working. I don't think they're proposing to go down the exact same path that 23 did.
I think there's an NPRN out that's it's got all the words that they're going to performance-oriented.
Yeah, and I think there's different ways to do that.
Okay.
Part 23 went one way. I don't know if they're going to go down the same way for 27, 29.
All right.
Yeah.
Next question there, pass the mic. And
Hi.
go ahead and tell us who you are.
Carl Dietrich with Terrafugia.
Okay.
Question for Ife and Dave. So in the F-38 group in ASTM, the unmanned group, there is a standard, I think it's F-3269 for bounded complex control, and relating to non-deterministic systems and things of that nature, it appeared to be a possible interesting way of introducing that type of technology within a certified outer loop. I'm just wondering, are you guys familiar with that, or is there conversation about using that type of standard as a way of introducing machine learning type systems into certified aviation.
Yeah. So yeah, I've participated in that working group a few times. Is this on? Yeah. So we're very much aware of that. We've commented on that particular document. I think it's talking about runtime assurance, if I'm understanding that correctly. Yes. Yeah. So yeah, and that's actually, I actually took that out of the slide. I had a picture on runtime assurance, but the issue paper does reference that work.
And just to add to that, the FAA is engaged with NASA, mostly Armstrong, a little bit of Langley, to do research in this arena. And NASA has a flying UAS that we've been using as a test bed, and we're trying to mature some of those the standards and the MOCs using that vehicle.
Thank you.
Is that another question? I think we're probably run over time, and everybody's looking forward to the cocktails at 6. So thank you for your attendance. And if you got some more questions, they'll remain here for a couple of minutes to answer any individual questions you have. Thank you very much.